on the laptop again because I was messing with my other computer. So I'm not 100% sure I'll be able to access the MyMathLab.
Oh.
Which I probably can, I just didn't want to have to worry about messing with access codes and stuff.
Right.
This is faster. But we get infinitely the same.
Oh man, question 1 is about the homework that's due tonight, which I haven't done. Can you start out with something easier?
Probably not.
Okay.
I was a father. I took you on a date. Wait, I'm gonna take you on a date anyway, but. Okay, she would have. Let's go.
Anyone with kids?
Three out of the 5 have kids.
I may need you to help walk me through this. I did all the reading, but I don't really.
Haven't gotten hold of it yet.
I'm just not sure I understand it very well.
It's all good. Okay. So I need to get my bearings too. It's been like a couple hours since I was I didn't get all the way through this homework because I had a problem that I couldn't solve for z on one side, and I was doing implicit differentiation wrong, and it was a mess. So I just got frustrated and went to something else, and it's out of my mind now.
Oh boy, I've done that.
Okay, I think on this one. Yeah.
So
we should be able to plug in the values they gave us for x and y into the z equation, and then
differentiate it
for u and then for v. That's appropriate.
Okay, so we just plug them in as they are. We don't take a derivative or anything?
Not yet.
Not yet, right? Okay.
We can do a derivative now, and that's a way to do it, but this is another
Let's not yet.
We want.
So.
Oh wait, am I looking at the right notes even? General notes. Because I'm noticing that I'll cancel out all the u's if we do that. So it makes me think that I might be.
Oh, that maybe we don't. Yeah, but even if you take the derivatives, there would not be u's anyway, right?
How did I do this earlier? What am I forgetting?
If the u's do cancel, is the derivative just 1 or 0? It would be 0 because it'd be a constant, right?
Yeah, it would be. Oh, so yeah, that could totally be it then if it's, or no, it would be. It would either be all real numbers or no real numbers because there's no u. You'd either get down to constant equals constant or constant equals different constant.
So what would we put? 0?
I don't know. It wants an exact answer. So I'm very confused right now.
Well, it would be a constant, right? Wouldn't it? So the derivative of a constant is 0. Or am I thinking not right?
That is the derivative of a constant. I'm wondering if you do differentiate it beforehand.
Well,
looking at the chain rule notes, and yeah, I think that is what you end up doing.
Differentiating it first. With respect to u?
Or first you would differentiate z1, or you just differentiate everything, each equation in terms of their equations and multiply. So you'd have like z sub x and x sub u, and you'd multiply those together. Or dz over dx and dx over du to get to du.
Okay, so step 1, dz over dx. Okay. Let's see. What is the derivative of the inverse of tangent?
It's 1 over 1 plus x squared, or u squared, or u subs.
Yeah, okay.
And y is acting as a constant here, so I think it ended up having a 1 over y on an extra y somewhere.
Yeah, times by 1 over y.
It's pretending to be a constant.
So for that, did you get 2 over y times 1 plus x over y squared?
Y times 1 plus? Oh, yeah. I had distributed the y out to...
Oh, okay. Yeah, cool.
It's like y plus x squared over y. So that's the same thing, so.
Yeah. Okay, so after we've done z, then we do x u, dx du. Okay.
I think that should just be cos v, right?
Yeah.
Like he's pretending to be a constant.
And then y over u sine v. I feel like I got this much. I just wasn't quite sure how to put them together because the equations all had w's in them, and where the heck does a w come from?
It's just the w is just the name of a function they used. It's like using f as a function name normally.
Okay. So now that we have these, do we need to do them in terms of y and v, or no?
Or you would, to get to the z equation in terms of y and v from this point, you multiply the two derivatives. So the zx and the xu, so the dx's cancel. You're left with dz over du.
Oh my goodness, thank you. Okay. So our answer should be 2 cosine v over y plus x squared over y.
Wait. So you have to do it for the... Sorry, you're ahead of me. You have to do it for the y values as well. So I'm stuck on that in my head right now because that works a little bit.
Wait, what do you mean the y values?
Right? Because
I'm so sorry.
In the chain rule notes, it had us stick it into a matrix. One spot of the matrix being for u's, one spot being for v's. Would be f sub x xu plus f of y yu.
Sassy, stop.
If that makes sense. So it'd be the
So how come multiplying the dx du and dz dx doesn't turn out to be dz du?
It does, but it's half of it. You have to do it for the y's as well, because that's only one of the variables in z. That's what.
Oh, okay.
This is asking us to do it by chain rule, not by partials with constraints. Or chain rule with constraints and stuff.
Yeah. Okay, so now the derivative of z dy. What'd you get? 2x. Not quite, huh? Because y is on the bottom.
So y is a y inverse. So y to -1. So when you differentiate that, does it put a y squared on the bottom? Like x over y squared? Can you differentiate that? Unless I'm crazy, which is possible.
Let me see.
Yeah, so I did miss that.
It'd be -2 over y squared.
-2x.
Not 2. -x, yeah.
-x over y squared is the
derivative. Okay. So that's going to equal Do you get -2x over y squared plus x squared?
Yes.
Sweet. Okay, multiply. And now we're going to multiply this by dy du. Right?
Yes.
Okay. And then do we add those two together to get dz over du?
You'll want to plug in values for x and y once you have your added together, because it all needs to be in terms of u and v.
And we can just plug in those values there. U cosine v.
Yep.
That's a lot of work.
It is.
Oh, okay. What did you find? Oh, look at those tomatoes. They're kind of cucky, huh? Cool. Thank you, sweetie. Yeah, okay, go play soccer ball. I'm getting 0. How did you get that?
You put in the XU or Y, the X part or the Y part twice.
Wait, say that one more time.
Sine V. One fraction should have a cosine and one fraction should have a sine. So you should.
Yes, correct. I can't come, sweetie. I'll come in a little bit, okay? We'll play with Daddy for a little bit.
That shouldn't go to 0 if one is a cosine and one is a sine.
Well, I got one, so...
Oh, wait, does it? Wait.
Well, mine... So, to the first one, I just multiplied y over y so that I could get the same denominator as the other one, which is y squared plus x squared.
Okay, I made a mistake in mine, I see.
Okay.
Yeah, that is 0.
So yeah, I got 2y cosine v minus 2x sine v, but then since... Anyway, I got 0.
0 is correct. I put my thing in the wrong spot.
Okay, if you're sure, because I'm not always right.
No, I multiplied everything by the y I stuck on top instead of only.
Oh, okay. That makes sense. So now we have to do that whole thing for v instead.
Yep.
No, boy. Thank you. Thank you. It's a bummer that it was 0 anyway.
I know.
Hey, you should say, Daddy, can we go drive the car? Go, Daddy. Sheld. Maybe you should take Catalina to the car dealership. Huh?
Are you muted?
No. She just doesn't want to play with you anymore. But I can't have her playing with me.
Go upstairs and play with your house. Okay, yeah.
2 over y plus x squared.
Yes.
Maybe, Sheldon, maybe Em would watch her so you can go. Yes.
It's gonna be a drink too, okay?
2x.
Hey, it's good. Not only have we 20 minutes almost. Just 1 more minute and I'll keep playing. Come outside with Daddy. Come on. Go with the chalk. Come on. Go with the chalk.
Oh, thank you, sweetie.
So is this the game?
All right, so just making sure you got negative u sine v and u cosine v for the derivatives.
Yep.
Okay. I'm sorry, I'm going slow here.
That's fine. You have a little girl talking to you.
Yes, she's very busy today. Okay, what am I doing wrong?
What are you getting?
Okay, so I'm getting confused because we multiply them together and then we put in the x and y values here. But they're just so similar that I am skipping one or the other.
I'm not like trying to trick myself because the y matches the sine, so the sines are together on the top and the coses are together on the top.
Are they?
Because y is u sine, the y is attached to the sine v because we took a derivative of the trig function.
I think I just copied these numbers down wrong. Yeah. And then on the bottom we have.
The bottom is
I didn't even do the bottom before because it went to 0.
Oh yeah. That'll do.
So. Oh, just u times 1, so it's u, right? Is that what you have?
On the bottom I had u squared, but.
Oh, that's what I meant.
Okay.
Sorry. And then, wait, so you have it, because 2u comes out on the top, so that's why it's not squared anymore.
Mm-hmm.
Okay. Awesome. Okay. And do we just plug?
Yep, just plug it into the ones we got.
So that's like 0 and then 2 over 4.7? Or am I missing something here?
Oh, I put in the wrong number. I put in pi.
Am I thinking correctly?
Yes.
Oh, but he wants us to do actual numbers. So I need a calculator.
That's an irrational number.
Yeah. Round to the nearest thousandth, so 0.426. Is that what you got?
Yep. Negative 0.426.
Yeah. Sweet.
Submit. Darn it. Every time.
Next. All right. This is the one. This is the one with constrained variables, correct?
Yeah. Or multiple are independent. Sadly.
Yeah.
So much easier the other way.
Okay, so the first approach is to replace t with what is in terms of x, y, and z.
Mm-hmm.
And then take partial derivatives with respect to x. This is by far the quickest route. It's already in t, right? So we just need to plug t in.
Mm-hmm. Or this one would be in respect to y. But
Oh, sorry, what did you say?
I was mostly talking to myself. So.
Oh, okay.
This one's in respect to y, not to x. Somehow I was thinking x.
Oh, because what I just read was with respect to x.
Oh, that'll do it.
Yeah. So 0 plus 2 plus 0 plus. So you get 2 plus sine of x plus y?
Wait. That would still be differentiated, right? So it'd be cos x plus y.
Huh, yeah.
Okay.
But is it just 2 plus the cosine of x plus y?
It is.
That's not too bad. Oh, that's why there's 6 of these. Okay. My question is, how is it going to be different now? Because we're gonna.
So it is marginally different.
It's in terms of x.
Or x is the dependent variable this time instead of t.
So now we're gonna make it x is equal to t minus y.
Yes. So much.
Oh, I'm gonna figure this out. I'm so glad you're so helpful. So. No, really.
I think I'm just saying things and it happens to be useful.
That's very helpful. Okay, so now we plug t minus y in to all of the x's.
Yep.
Well, that stinks. Sassy. Okay. Did you get negative 6t plus 6y plus 2?
I got 6t minus 6y plus 2.
Why'd you get minus 6y?
What did you plug in for x?
T minus y. Sassy, stop. But when you squared it, doesn't the negative go away?
I kept it in the, I didn't distribute, I did the distributive property in the differentiation. So I treated it like the squared was a sign or something. I just didn't worry about it.
We should still be getting the same answer though, should we not?
Yeah. So I'm trying to figure out how our signs are inverted.
How did that not work? Because if you multiply it out, the
negative should stay with the y, so.
Well, but when you multiply it out, it ends up being y squared.
It does.
There is a negative 6 on the first y, that's why it's negative 6t.
Huh. That's weird. Huh. I think you're probably right, because I was being lazy.
I don't know.
It's weird that those are different.
Because if that is, like, I've never used that distributive property, but if it is, then it should work the same way, right? It ought to.
It should. But apparently the signs get mixed up when you do it the cheater way. Yes, I mean, what? Math, what are you doing?
You're failing us. Don't do that.
You had one job, Math. Like, what? Why is that? I'm not going to worry about it. I'll just not do it the lazy way anymore. Because it is very clearly different for some reason.
Yeah, we have the same numbers though, so that's promising.
Just somehow the signs get switched if you.
Right.
Which doesn't make sense because use substitution should be a thing.
Yes. Try a good thing I never understood that.
Wow.
Okay, this time it's T again, right? Or no?
You know, use the same W equation as the first one because T is the one that switched around. We're just doing it in terms of a different variable.
What variable this? Okay.
It was Z instead of Y.
It's Z. Okay.
So it's just
2. That's so nice. I like that one.
And E should be the same because there's still only one Z.
Wait. Oh, I skipped one. When I scrolled down, it missed one.
Oh, wow.
Okay. So I answered the second one. Okay, so now dt. And we're going to plug t minus x in for y, right?
Yep.
3x squared plus. These aren't too bad once you figure them out.
Yeah.
Did you get 2 plus the cosine of t?
Yep. 2 plus cost.
This one again.
Oh my goodness. I know why I was off by a negative factor.
Why?
The derivative of minus y is -1. So I should have stuck a negative sign out front.
You're right.
That's what I did.
Good call there.
So I'm like, oh, the signs worked this time. So I can still do it the lazy way. That's good.
That is exciting. So 16 minus 6y this time. Plus cosine of t?
Yep.
When are these applicable?
When or what?
Like, when do you ever use these?
If you're like, if it's you have a vector function and you want to find a derivative for it.
Okay. Almost done.
Mm-hmm.
All right, this is one that I thought I knew what I was doing, and then I kept getting it wrong, and I don't think I ever figured out what I was doing wrong.
That I realized I didn't do the homework on because it was a part C, and I assumed there wasn't a part C when I was working on it.
Yeah.
I was like, oh.
Perfect. Let's see. I kept doing what it was saying to do. I guess not, but. Let's see. Tangent spaces. So, any right ideas as to how to go about this?
So I had in my notes the equation of a tangent plane would be z minus fab equals the f part of the tangent in terms of f dash afrach. I can't speak. This is terrible. But pretty much what we were doing. It's. Why can't I do this? Here's the thing I can type in. FAB is z. But this is the point. Is
So, like the linearization thing?
exactly. It's linearization, but it's in multiple variables. That's the word I was looking
for. Okay. So, do we need the derivative of each of the directions?
Yes.
Okay. Start there.
within parametrics, so we'd have to convert back to x's and y's. Sorry, I'm slower right now.
Right. Do I do that first or?
So I'm looking at the first thing we solve for, probably, because it's in terms of x's and y's. I was looking at the different equations it gave us, and I was very confused for a while.
Yeah. How do you convert that, though?
Maybe you don't. So what it's saying here is not actually that helpful, and I was really hoping.
We can plug in the theta and z, can't we? And that'll give us
oh, that might be
that will give us a vector.
Yeah, that might be what I was thinking of. Because yeah, that's probably it.
Okay, question is, do we do it now or after we've differentiated it? Or after we've gotten the derivative?
So the derivative will give us a slope. If we do it now, it'll give us a point.
Which do we want?
Well, we have P0, and we can get another point, and that gives us delta x. So
okay,
do it now.
So let's do it now. So theta's pi over 3, 2 sine 2 pi over 3. And z is -1.
And so delta x should be
Why are you looking for delta x?
No. So the P0 they gave us is this point. Oh, that's okay. No duh.
Wow. Okay.
I feel really smart right now. Okay. So probably want to use derivatives.
We do want to use the derivative now. What is with the vector RU and RV?
That's R in terms of U and R in terms of
Yeah,
V.
but we don't have U and V. We have
U is
theta and Z.
U is the first value, V is the second value. Just general terms.
Oh, so we can use theta and Z.
Theta, RZ. Which is probably what we should do. Get those values. Theta. I do cross product?
Okay. Oh, hey. Is this one of them? No.
Sorry, what'd you say?
I'm just looking at my answers. I'm not sure. I think it's either A or C. I'm thinking it's C.
No, you're way ahead of me, so give me a sec and I'll catch up.
But all I've done is taken the derivative and plugged the numbers in.
Yeah. So far I've taken the cross product of R theta and RZ, and now I'm plugging in the thetas.
Hmm. Or maybe, I don't know. Why is it equal to 4? Any luck?
I have a negative sign I shouldn't have otherwise.
Oh, me too. Actually, I had 2 negative signs.
I only have 1. But that's still 1 more than I need. Darn it.
You have a 2 and a 2.
I have a 2 and a 2 root 3. I don't have a 12.
I don't have a 12 at all either, which is making me think it's maybe B. Do you have a 2 in the X position?
Yeah, I have a -2 in the x position.
Oh, me too, but I have a -2 root 3 in the y position.
I don't. Darn. I have positive in the y position.
Hmm.
Why is it? What? And then, so I do have 0 in the z position through it, so it probably is.
That's what I'm thinking.
Probably is my c.
2x plus 2 root.
Yep.
Y equals 0.
That's what I'm thinking. I don't know why I have a negative, but it's probably. Wait.
I don't know. That's what I'm thinking too, because I also have a 0. Where would the 12 have come from?
I don't know.
I don't know.
Use this. That's it.
Okay, so the Cartesian equation for the surface, we're looking for the Cartesian equation of the cylinder, right?
Yes.
So this is where we need to convert it back.
So is the thing universal to do? The x is r sine theta, or r cos theta, y is r sine theta.
Yeah, that doesn't really work though, because they're both in sines.
I know. Or after you derivate them, it's even worse, kind of, so that doesn't help. Just kidding.
Yeah, that doesn't work either. Let's see. What is a circular cylinder? It's going to be x squared plus y squared plus z, correct?
Probably. I think so.
Well, because yeah, it has to be. Because if anything was under it, it wouldn't be a circular, it would be elliptical.
Yeah.
So we just need to figure out what is with them. Equal to 4. What do you think it'd be y minus 2? Just looking at the graphs. I mean, this isn't the best way to do it, but it looks like the y coordinate would be 2 and 0.
This is for the whole cylinder, though.
Yeah, I know.
From 2 to 0.
So like x squared plus y minus 2 squared in parentheses.
Oh.
Do you know what I'm saying?
Yes. Yeah, I know what you're saying.
Would that be correct thinking or probably not? I just don't know where that would come from.
Yeah, that would be correct thinking. It's also cheating.
Awesome. Cheat away. What are you finding?
No, I mean you're looking down ahead, and that's clearly not something they ever intend you to do because it's available at the start.
Right.
Yeah. Totally didn't in my AP Physics exams look ahead to remind myself what equations were. It's like, oh, I'm gonna find a question that gives me this equation in a form, so I'll remember it, or the question asks me what it is. But that's not relevant here.
Let's see.
So it has to equal 4.
Yeah, because the radius is 2.
Working back from that way, that we know what radius is, which helps us for cylindrical coordinates.
Right. Would z be negative? Or is it positive?
I don't know. I think z might just stay z.
So, if I'm looking at the graph, right, x squared minus...
Because
I mean, x squared is 0, right?
Yeah.
It starts where x is 0. X squared plus y minus 2 squared plus z is equal to 4.
I mean, it's going to be, it's x squared over something, y squared over something.
Why? Because if it was over something, wouldn't that make it elliptical?
It is elliptical.
Not circular?
Because the point we have is, I don't know. It doesn't, oh, it says circular cylinder. Okay.
It does say circular, yeah. But can we count on that? I think the point is more referring to where the tangent line is.
Oh, and because if it was an ellipse, it wouldn't be a 4 on the end, too.
Right.
Okay. So, I mean, how are we supposed to get that?
I'm not sure. Because it doesn't work by the rules, like the R sign.
It's not, yeah. I mean, so this, it might just, I don't know, but if you're going to
It kind of works.
It would have to be cylindrical coordinates. Especially because the, oh wait, maybe you have to get the full derivative instead of just the partials. To do a full derivative, you would have to, from here, no, full derivative is matrix, what? Well, that shut that idea down.
That didn't work, huh?
No, full matrix gives us, or full derivative gives us a matrix.
Oh, yeah.
Which is slightly less than helpful.
If you were to pick a graph for this.
A graph for the plane that's tangent to it. So we know that P0 is root 3, 3, -1. That's probably shared by all of them, though. Yeah.
Maybe. I feel like it's your C. Because root 3. Well, 2 root 3 plus 2y. It's going to be, I mean, it's hard to tell from the graph because it's not like perfect, but it's going to be x over root 3. So 1 over root 3. Well, that's just a line. We need a surface or a plane.
Yeah. So plane is just a line with z being factored in. So, but which way is it facing?
So that's why I feel like A is kind of. Okay, your C. My A is your C. Sorry. I feel like that's the one that's facing towards us with the Z. The other one looks like it's laying underneath it.
Mm-hmm.
But how are you supposed to tell by this?
So we know that, so the plane has to be tangent to the point. It's a collection of tangent lines.
Right. So
this. So it's going to be tangent that point's on the outside of the cylinder, correct?
Yes.
It's not a solid, it's just outside. So I think.
So would you think C? Or would you think A? I just can't tell by the picture. Come on in. I'm just finishing up my group thing. You found it.
I just gave up. There was outside. So.
Perfect.
Yeah, I think it's your A.
Your C. Awesome. I guess we'll know in a second, huh?
Yeah. Okay. Let's do this.
Oh dear. That's a good thing these don't count for very much, huh?
Yep. Let's see. Question 1. What did we do wrong? -2. What?
We got most. Wait, what?
What?
We got most of. Second one correct. We got -2 wrong.
What?
There was no U on the bottom. Oh. Well, that's a bummer.
That sense not make.
What did we put on here?
Maybe.
Oh man. Okay. I didn't put 2 plus. I just did 2 cosine xy. That's dumb. Yours was correct. You had it right.
Oh. Huh.
Great. That's confusing because F is correct, but we didn't get that one right. That doesn't make sense.
Oh, that one they wanted us to distribute out the 6. Oh, whoa, are you, what? Wait. Was this the one that was the big sign issue on number 2?
Yeah, but then F we got correct, so.
Wait.
I think that he's done something funny there.
I bet he did what I did.
Bet he did. Oh, dang.
Because it would make sense to take the lazy way. Lazy way is.
Does he ever fix that? We should email him about that.
I'll see if he posted on the front page, because last time it was an error.
Oh, we weren't supposed to have a Z at all on the Cartesian equation.
What? What's the cylinder?
Yeah, apparently not. I think he did that wrong too. Because that's not a cylinder, that's a circle.
And apparently it was 12.
Huh. Well, awesome.
At least we got the bottom one right.
Yes, we did. I think we should ask about that second one too.
Yep.
Awesome. Well, thanks. I learned a lot. It was a very productive session for me.
It was. That's good. Well, let's see if there's something posted on the homepage. No, I don't think there was.
I don't think there was. Awesome. All right. Well, guess I'll see you next week.
Okay. See ya.
Bye.